In today's class, we are going to learn about functions. So functions are basically special types of relation. Okay, so how do we define a function? So first one, we consider two sets, let A and B be two non-empty sets. Second thing is that each and every element of set A has unique association. Unique here meaning only one association with elements of set B is called a function. From A to B. Say we take a set A and a set B. Say we have 1, 2, 3 here, and we have A, B, A, C, B, D. So first of all, each and every element of set A should have an association, and it should have a unique association. Means 1 is say related to A. So 1 can be related to any one of the number. So it has a unique association. 2 can be related to any element in set B. Say 2 is related to A itself. There is no problem. But 2 should have a unique association. That is, it should have only one association. It cannot have two associations. Like 2 cannot be associated with A as well as with B. That is not possible. And say 3 is associated to D. So this is our function F. Okay. So each and every element is associated, and each and every element has a unique association. 1 is associated with only one element, 2 is associated with only one element, 3 is also associated with only one element. So this is a function. Okay. So let's consider an example. A equals to pi r square. So here r is basically our independent variable. And A is our dependent variable, because the value of A depends upon the value of R. So R is basically the input and A is basically our output. So consider this like a machine in a factory. So this machine is basically A equals to pi r square. So input that you give in this machine is the value of R. Input is basically R. R is the independent variable, and the output that you receive after putting the value of R is A. So say R is 0. So the value of A is 0. Say R is 1. So value of A is pi. So value of R is 2. So value of A is 4 pi. And this keeps on. Now here r equals to -1. This is an invalid input. As we know that radius cannot be negative, so if r equals to -1 we say, we get a value of a, but this input itself is invalid. You also need to consider what input would be valid and what input would be invalid in case of different functions. Okay. So a valid input is called the domain, or basically this set A is the set of domain because each and every element of this is associated. All of these elements are valid inputs in this case. And output received by inserting the whole of domain is the range. So once we put the domain, the values that we get, like A and D in this case, only A and D comes in the set of range. So range is basically a function of A. When you put all the values of the set of domain, the values that you get, that is A and D, is your range. And this set B is called a set of codomain. Like we did in relations as well, this set is called a set of codomain. So any one particular output, if we take output, an output is known as image of the input, and input is known as pre-image of output. So if I say this A or say D, so D is our image, and what will be the pre-image of D is 3. So D is the image of 3 and 3 is the pre-image of D. So this is how what image and pre-image means. And 1, 2, 3 is the set of domain. Each and every element of the first set is the set of domain. And after inserting these values, the values that we get, that is A, D, this is the set of range. And this whole set, that is A, B, C, D or A, C, B, D, is the set of codomain. Okay. So we have a definition of a real valued function. If the domain and range of function f are subsets of real numbers, R here denotes real numbers, then f is said to be a real valued function. So if the domain and range both are real numbers, then we say that the function is a real valued function. Okay, to understand the domain and range and this statement more properly, let's see a rule. This is not an official rule, this is for your understanding. I call it the child and birth mother rule. So let's say we have a set like this and another set like this. So the first set denotes the set of children or child. Say child 1, child 2, child 3, child 4. and say this is the set of all both mothers. So say we have a birth mother named A, B, C, D and E. So now if I say 1 is associated with A, 2 is associated with C, 2 is also associated with B, 3 is associated with D and 4 is not associated at all. Okay, so will this be a function or not? So when we think of it as children and both mother, so 1 is a child, so it can have a mother. So 1 has a mother, it's fine, only one mother, so it's fine. 2 has 2 birth mothers. Can it be possible that one child has 2 birth mothers? It is not possible. So from this only we can say that this is not a function, as 2 is associated with 2 elements in codomain. It is not a function. Not only this, there is one more problem, that this child does not has a mother at all. So can it be possible that a child just pops up from somewhere? That is not possible. So a child needs to have a mother. So every set, each and every element of set A, the first set, must have a unique association. It should have one association and only one association. So 4 is not associated at all with any element. So that is also the reason why this is not a function. Number point 2, as 4 in the set of domain has no association with any element in the set of codomain, so it is not a function. So this is our first example. Let's take one more example. So example 2. See, child number 1, 2, 3 and 4, and birth mother number 1, A, B, C, D and E. Say 1 is associated with A, 2 is associated with D, 4 is associated with D and C is associated with B. So now this child 1 is associated with A. This child comes from mother A. Number 2 child comes from the mother D. Number 4 child also comes from the mother D. So a mother has 2 children, so that is not an issue. So this is not a problem. But one child cannot have 2 mothers. So if 1 has 2 associations, then that is not possible. But if D has 2 or more associations, that is not an issue. That is possible, because a mother can have many children. And 3 is associated with B, so no problem. Now, in this, C and E is not associated. When a mother has no child, so that case is also possible. But if a child has no mother, that is not possible. That is why this is a function. Here, each and every element in domain has a unique association with elements in codomain Therefore, this represents a function. Okay, so let's solve two questions. First question, let n, that is the set of natural numbers, be the set of natural numbers and the relation R be defined on n such that R equals to x comma y, such that y equals to 2x and x comma y belongs to natural number. So solution, over here we have x comma y and y equals to 2x. So first of all, we need to understand which one is our set of domain and which is the set of codomain. So x here represents domain and y denotes the set of codomain or the set of range. And y, as we saw earlier also, y is the dependent variable, y is dependent upon the values of x, and x is the independent. The independent is basically the input or the set of domain, and the output is the set of range. So here the domain is n, and if you put natural numbers in place of x, say 1, if you put, so 2 ones are 2. If you put 2, then you get 2 twos are 4. If you put 3, 3 twos are 6. If you get 4, so 4 twos are 8, and so on. So here the domain is the set of natural numbers, and the range is all the even natural numbers. And as we can see, each and every element, say if you take x as 25, then y is 50. No other value of x will give you 50. So x equals to only 25 will give us y equals to 50. So that is why each and every element has a unique association, and each and every element has a unique association with the elements in codomain. So R is a function. So this is how we write the language. And the second one, examine each of the following relations given below and state in each case giving reasons whether it is a function or not. So but 1, r equals to 2, 1, 3, 1, 4, 2. So solution. In this case, what you can do is you can draw the arrow diagrams like this to understand this more clearly. Say first in the set of domain we'll write all the first elements, that is 2, 3 and 4. And in this one we'll write all the second elements, that is 1 and 2. So 2 is associated with 1, 3 is associated with 1 and 4 is associated with 2. As we can see, each and every element or each and every child is associated as a mother, and no child has two mothers. So every child has a unique association with an element in the second set. So you'll write this language exactly, each and every element this is our relation R, therefore relation R is a function. Each and every element in domain has a unique association with elements in codomain therefore R represents a function. Number 2, say R equals to 2, 3, 2, 2, 2, 4, 3, 3, 4, 4. So let's draw the arrow diagram again. We have in the first set, that is 2, 3 and 4, and in the second set we have 2, 4, 3, 4, means 2, 4 and 3. We are not repeating 4 because we know that repetition in case of set does not make any sense, so we can write them once, that's fine. So 2 is associated with 2, 2 is associated with 4, 3 is associated with 3 and 4 is also associated with 4. So a mother having 2 children is not a big deal, it's fine. But a child having 2 mothers is not possible because a child cannot have 2 birth mothers. So this relation R is not a function, as 2 in the domain has association with 2 and 4 in codomain, that is no unique association therefore R is not a function. Here R was denoting the relation, so R is not a function. Okay. Now we'll understand what this represents graphically. So graphically, if you see, we'll use some examples of graphs to understand this. Say, we start with some basic polynomial functions. So first one is the identity function. Identity function is basically f of x equals to x. Okay. I'm drawing with pen. I'm not using scale and pencil, but make sure you use scale and pencil. I'm drawing with pen so that it is visible to you and it's clear to you as well. Okay. So this is our origin, x-axis, y-axis. So say 1, 2, 3, 4, 1, 2, 3, 4. So what is happening is f of x equals to x at x value 1. F of x is also 1. F of 1 is basically 1. F of 2 will be also equals to 2. So what we are getting is like this: 2 equals to 2, 3 equals to 3, 4 equals to 4. So 3 and 3 over here, 4 and 4 over here. So what happens is we are getting a straight line in this way. So what we are getting is a straight line in this way. So this function is a f of x equals to x. Okay. Now let's understand how we find domain and range. In this case, for f of x equals to x, is there any value of x that you put and you get no solution? So there is no value of x in case of real number if you put that value and you will not get a solution. Say if you put, say x is pi, so f of pi is basically pi. F of minus 30 will be 30. F of minus 40 will be minus 40. F of 1000 will be 1000, because we are just replacing x with 1000. So f of 1000 equals to 1000. So each and every value is defined. So domain is the set of whole real numbers, because each and every value in this real number we can put in case of f of x equals to x. So domain is a real number. Now comes the range. Okay, so graphically when we see, domain is basically what we can put in the x-axis. So in the x-axis all values are possible. So therefore domain is R, the set of real numbers. And for range, after putting this value of x, what values you get in the y-axis is basically the range. So if you see 0 we are getting, and in the positive all the values we are getting. So 0 to infinity is there, and from 0 we are also getting in the negative all the numbers. So minus infinity to 0 is also there. So from minus infinity to plus infinity we get all the values. So that is why a range is also the set of real numbers. Okay. Now, as we see, this graph is symmetric about origin. Symmetric about origin means if you say you place a mirror in this origin, so this and this basically are like mirror images in this case. That is why we say that this is symmetric about origin. Or you can also check that f of minus x, if you see, if you put minus x in place of x, then you get minus x, and minus x is basically f of x. F of minus x equals to minus f of x means that this is an odd function. Odd function is basically if f of minus x is minus f of x, then it's odd function. And odd functions are always symmetric about origin. F of minus x is, if you put in place of x minus x, then we get minus x. And x is basically f of x. So f of minus x is minus f of x. So whenever we get f of minus x as minus f of x, it's called an odd function. And odd functions are always symmetric about origin. As we can see also, this is symmetric about origin. If you place this over here, then what you see is this point basically acts as a mirror. So whatever is here, same, we have a reflection in this case. So we say that this is symmetric about origin. Second function is the constant function. So constant function looks like this. Constant function is basically f of x equals to any constant value, say 5. One, 2, 3, 4, 5, 6. -1, origin, -2, -3, -4, -5. -1, -2, -3, and so on. 1, 2, 3, 4, 5. So f of x equals to 5 means if you put any value of x, it does not matter what you put the value of x, you will always get the value as 5 only. So this is a constant value that you will always get 5. So what we get is a line parallel to the x-axis and passing through 5 in the y-axis. So whatever the value of x, the value of y is always going to become 5, or value of f of x is always going to become 5. So it does not matter what value of x we put, the value of y is always going to become 5. So here, domain. In domain you can put any real number, so the domain is R. Number 2, the range is what we are getting as the value in the y-axis is only 5, nothing else. So the range will become a singleton set, that is 5. Third point, f of minus x. No matter the value of x, the value is going to remain as 5 only. So f of minus x is 5. That is, 5 is basically f of x. So f of minus x is equals to the f of x. So this implies this function is an even function. Whenever f of minus x equals to minus f of x, then we say that it's an odd function, and f of minus x equals to f of x, then we say that it is an even function. So the fourth point, since it's an even functions are always symmetric about y-axis. Odd functions are symmetric about origin, and even functions are symmetric about y-axis. This y-axis acts like a line where it divides this into two parts, such that this y-axis is acting like a mirror. So whatever is there in the left, same, a reflection is there in the opposite side. In this case, only this point was acting like a mirror, where this was reflecting this one over to this side. In this case, this whole line acts as a mirror. This whole line acts as a mirror, and there is a reflection of this one. Okay. So third function, f of x equals to x square. Whenever you will be asked to plot this, you need to take certain values of x. For that you need to find the values of f of x and you need to plot them. So say if we put x equals to 1, we get f of 1 as 1 square, that is 1. So f of 1 is 1. F of 2 if we put, so 2 equals to 2 square, that is 4. F of 2 is 4. F of 3 if you put 3 square, that is 9. F of 3 we get as 9. So this is somewhere over here. So as we keep on increasing values of x, the values of y keeps on increasing in terms of square. So f of minus 1 square is basically 1. F of minus 2 square is 4. Minus 3 square is 9, and so on. So what we get is a graph like this. So this is the graph of f of x equals to x square. Okay, so even before solving we can see that this is a reflection about the y-axis. So if we keep like this, so this y-axis acts like a mirror, and what is there in the left, there is a mirror image of that in the other side. So here this is symmetric about the y-axis. Okay, so first over here, domain. So in case of domain, you can place any value in this place of x, you will get a value of f of x. If you put say x equals to 25, so you get f of x, that is f of 25 as 25 square. So value of 25 square will become 625. If you put any value of x, say minus 20, so f of minus 20 will be equals to minus 20 whole square. Minus 20 whole square is 400. So any value of x you put, you will always get a value f of x. So domain is a real number. This is defined for all values in the x-axis. Second case, when we talk about the range, in case of range, what we are getting in the y-axis are all the values that is above 0. From below 0, we do not get any value. We get f of 0 equals to 0. So we are getting 0 as the minimum number, and after that the values keep on increasing. So this goes till infinity as x will increase to infinity. So range will be from 0 to infinity, including 0, and infinity is not a number, we cannot include infinity, so infinity is excluded. Number third one, f of minus x, if we check, so we get minus x whole square. Minus x whole square is basically x square, and x square is basically equals to f of x. So f of minus x is f of x, so this is an even function. And even functions are symmetric about y-axis. Okay, the fourth graph. This is our last graph for today. With this we'll conclude the class. We have a lot of graphs also remaining, and those are important graphs which we will complete in the next class. Fourth graph, y equals to x cube, or basically f of x equals to x cube. Y or f of x here represents the same thing basically. So we have x-axis, y-axis, x-axis 1, 2, 3, minus 1, minus 2, minus 3, minus 4, 1, 2, 3, 4, 5, 6, minus 1, minus 2, minus 3, minus 4, origin, x-axis, this is our y-axis. So if you put x as 1, f of 1 is 1, x as 2, f of 2 will become equals to 2 cube, that is 8. F of 3 will become 27. F of minus 1, f of 0 is 0. F of minus 1 is minus 1 cube, that is minus 1. F of minus 2 is minus 2 cube, that is minus 8. So f of minus 3 will become minus 27. So what is happening is, this is coming in this way. So this is our graph for f of x equals to x cube. So over here, the domain, In case of domain, we can put all the values of x, will get a valid output. So a valid input over here becomes the set of real numbers. Second, a range. Over here we are getting all the positive values, all the negative values, and also 0. Here we got only positive values only above x and 0. But in this case we are getting all the positive values, all the negative values, and also 0. So range is also here the set of real numbers. The third one, f of minus x equals to minus x whole cube. So this is equals to minus x cube, which is equals to minus f of x. So this means this is an odd function and this is symmetric about origin. So as we can see, if you take only this point, so this is symmetric about origin. This point acts like a mirror. What goes here, same is coming over here as well. So this point origin is acting like a mirror. Okay, with this we come to the end of today's lecture. We'll be dealing with more graphs. We have rational functions, then we have modulus function, signum function, then we have exponential function. We have a number of functions left. We'll be discussing them in the next lecture. Thank you.